Good morning, everyone. Welcome to our latest Lighting Design Lab webinar, Cost-Effective Code Compliance, Lighting and Electrical section. We're going to spend a little bit of time today talking about facets of the new energy code for Seattle as they affect lighting and electrical systems. Duane, can we go to the next slide, please?
Maybe. Let's give it a try here.
There we go. So just a little bit of housekeeping before we begin. I see that most of you have been to some of our webinars before, but just in case you haven't, a few things. Everybody is muted during the course of the webinar. There's just too many of us to be able to allow conversation back and forth much as we would like. So when you have questions, and please do have questions, use the chat feature in the control panel. I will see those questions, and either I or Duane or both of us will address them as appropriate. We may or may not address them at the very specific time that you asked them, but they will get addressed. There will be several online polls, particularly for this webinar at the very beginning. Please go ahead and participate in them. And after the webinar, go ahead and take the short survey. It's very helpful for us. It takes just a couple of moments, and it gives us some information about what you found useful, what perhaps we could do better, and maybe what you would like to see in the future. That would be very good. We will, as with all of our classes, have a recording of this presentation and the slide deck posted on our webpage coming up. And you'll notice in the handout section of the little interface there, there are several handouts that I have provided for you guys that have to do with lighting controls, network lighting controls, and luminaire level lighting controls, which are very helpful, I think, as all codes really push into more and more in-depth controls information. And of course, Lighting Design Lab, we are a branch of Seattle City Light, who is largely funding and bringing this program to you. And Duane, who is my co-presenter here, in fact, the primary presenter here, works for the Seattle Department of Construction and Inspections. We will go ahead and introduce ourselves in just a couple of moments, I promise you, for those who don't know it. But first, I'd like to gather a little bit of information about you guys so that may help us to tailor a little bit of how we address our remarks based on who the audience are. So if you would be so kind, first, please tell us a little bit about yourselves. In what part of the industry do you most closely identify? Are you a design ally, a construction ally, a sales manufacturer, facility professional, other? Go ahead and click in now if you'd be so kind. Oh, wait a minute. I apologize that we are having a little bit of difficulty with the polls. All right, well, apologies, it's not going to let me give you that one.
Would it help if I stop sharing, do you suppose?
No, it shouldn't. I think it's decided that we've already done the poll, so I'm going to do the next one. Sorry, maybe this one will work better for us, folks. Give this one a shot. My knowledge of the Seattle Energy Code is either just beginning, rudimentary, so-so, or extensive. Going to give you guys just a minute or so to actually go ahead. All right, I'm going to close and share that. So we've got a few people who are just beginning in the codes, excellent, or relatively rudimentary, and about half, maybe a little bit more than half, are either so-so or extensive. So we've got a wide range of folks here that we are addressing today. And then the last one that I'm going to ask you, if you don't mind, is if you are engaged in lighting projects, what percentage of those projects are retrofit versus new construction? And by retrofit, I'm actually including things like simple lighting retrofit projects, all the way up through, maybe a TI retrofit, say on a campus project or an office plate downtown or something like that. All right, going to give you guys just about another 10 seconds. And I'm going to close it. So about 20%, very few projects, 30% up to 20, 16% up to 50. So there are a significant number of you that are engaged in retrofit projects out there. So it's very interesting and useful to me. Thank you very much. Now we are going to stop the audience part of the project. And Duane, if you could go forward a little bit, please. I promised that we would introduce ourselves. My name is Sean Dara. For those who don't know me, I am a lighting designer, been one for about 30 years. So currently, my main role is actually as a lighting educator for the city of Seattle for the Lighting Design Lab, teaching classes like this, teaching network lighting controls classes and a variety of sustainability options. I also teach occasionally at the University of Washington. So that's a little bit about me. Duane, why don't you introduce yourself, folks?
So I'm coming up on my 10th year anniversary at the city. Hard to believe. Running the energy code development, and prior to that, I spent the rest of my career in private sector, usually in big firms doing giant projects as the technical guy. You might notice that if projects divide into sort of the design lead and the management lead and the technical lead, we all as technical people have a certain chip on our shoulders, but as being underappreciated. But I suspect that a lot of the people on this call are also a technical lead for their organization and been around here a long time. And I wrote, we got this on. I want the outcome of this presentation ideally would be that we're on top of this and it's not that difficult to get there. We can change a few habits and make this happen. So with that, lighting the way towards our environmental goals is not even worthy of a pun, but we have these major requirements in legislation in the state and in the city to move forward. And this is taken very seriously by current leadership, and we have to be on our way to making these dramatic reductions in energy consumption and greenhouse gas production. And we are more or less getting there. Now, Sean, what's getting us there in lighting? Sean, are you there? I
am very surprised that we're having some technical difficulties with the interface this morning. I assume you can hear me now.
Yes.
Perfect. Okay. Sorry, you surprised me. I thought you were going to do this one, but not a problem. So over the past 30 years, it will surprise no one to understand that lighting traditionally has kind of been the low-hanging fruit for savings with respect to energy codes, energy efficiency programs, all of these things. A huge driver of this really since, let's say, 2012. White light LEDs have been around longer than that. In fact, the first white light use of LED in Seattle that I'm aware of was the Amgen Helix Bridge over at Pier 90. It was designed in 1998, but it didn't come into real use on big projects until 2010, 2012, let's say. Since then, we've had amazing uptake of efficacy with respect to the light sources themselves. So they're using a tremendously lower amount of energy than they ever have before. And we're seeing a very large uptake with respect to retrofit projects, removing the old incandescent, metal halide, fluorescent, whatever the source is, and replacing them with LED. This has been fantastic. Next slide, Duane.
Hello. I'm sure the technology will be just fine in a moment.
Yeah, apologies, everyone. GoToWebinar is not our friend this morning. So as I mentioned, lighting has been the go-to low-hanging fruit for basically everybody, designers, utility programs, engineers, all of us, to try to save energy, save money, do all of these things. Now, these savings have been, as I mentioned, driven in large part through efficacy improvements in the light sources themselves, but also in a number of other ways, right? We've done a lot of research into human visual systems. We understand better how our eyes work. In fact, geez, in 2000 or so, we learned that there was a whole new set of receptors in the human eyes that had nothing to do with visual systems. So remarkable to believe that in 2000, we would be discovering new physiological issues with the eye, right? So couple that with the improvements in design and systems that we've had, and a lot of the cultural shifts, right? We have had a shift in which big swaths of our culture actually are becoming interested in making sure that we save the planet and are able to hand off a decent ecosystem for our children, right? So if you look at this great slide image here from the Design Lights Consortium, this is from a study that they did a few years ago, where they were looking at the uptake of LED products, both indoor and outdoor, and the types of energy savings annualized that we might see. Now, this slide is a little bit out of date, actually. The numbers are a little bit different than they are, but you'll notice if you slide over to the right, as we get more and more uptake of LED product, we see less and less improvement in our energy savings, right, on an annualized basis. So what this is leading to is the idea that now we have a light source that is universally dimmable, universally easily controllable, adding in the networked lighting controls and luminaire level lighting controls. If you don't know what that means, don't worry about it. We'll talk about it in the course of this discussion. But adding in those controls are going to be more and more important as we look at the aggregate energy savings that we're expecting from lighting. So quick little tidbit there. We'll talk more about these things as we move forward, but Duane, back to you.
Unfortunately, we don't have to do any of that with compact fluorescence anymore. Yeah, I've had a similar slide up for other talks we've had in the past. This, 4 basic principles that we used for developing the Seattle amendments, and today I just want to say we're on slides 3 and 4. We're trying to set up buildings such that without any major surgery they can get to our 2050 zero carbon target. One thing I wanted to mention from the mechanical side is the space heating is now required to be heat pump in most instances, but I just wanted you all to be aware from the electrical side that for individual apartments, 750 watts per habitable room is allowed to be electric resistance instead of that, or 1,000 watts in a corner room. So just keep that in mind. There'll still be some electric resistance load, but the idea was that once you get to such a tiny load, having a heat pump serving that 750 watts doesn't really make a lot of sense.
Hey, Duane, since we have a number of people who are relatively new at this, could you just give a quick maybe thumbnail description of what the 2050 goal is?
Sure. And I wonder, what in the world just happened? Can you believe this, that I'm not getting, okay, I was about to try to go back to our previous slides, but so our 2050 goal for Seattle is that operational energy use, including buildings and transportation, waste hauling, a few other things, gets to be completely and legitimately carbon neutral. And then there's some continuing discussion, which got sort of waylaid by the pandemic, but that we might step that up to a significantly earlier date. So this is very ambitious. Really need to get there. And there are parallel things happening in state legislation, like that one you see in the middle, 45% reduction by 2030. So statewide and in Seattle, we're going for some very ambitious goals over the next few decades. With water heating, there's another one that electric resistance and gas water heaters are in most cases not allowed. And once again, if you're doing electric design, you'll want to be planning for heat pump technology for that water heating. So to start us off here, and Sean, your expert here will be giving you much more detail, but basically we got two directions to go. You could have these LLLC fixtures every place, luminaire level lighting controls, which just, by the way, means that these are fixtures with their own controls, their own daylight sensors and occupancy sensors and controllers on board instead of room level lighting controls. Anyway, you can do that, or you can comply with all the rules for lighting controls that are in the code. Aux sensors in most kinds of spaces, and automatic time switches and manual switches and daylight controls. All that would be required. And even then, if you're taking that second path, large open office areas in Seattle need to be LLLC. In that list of exceptions, I just wanted to highlight one of them, that 0.01 watts per square foot in the exit access. First, I would explain that the exit access is sort of everything between your desk and the entrance to the stairwell, or a door straight to the outdoors, whereas the exit in building code world is the rest of the stair all the way down and out to the outside of the building. And so in that exit access, they're allowing that little bit, but that actually turns out to be, given the efficacy of these fixtures, you could have a dozen, maybe a couple dozen fixtures on a typical office floor and still be within that 0.01. And those can just stay on 24/7. That helps alleviate people's concern about having rooms go into full darkness. So, typical control strategies.
Thanks, Duane. So one of the things that we decided that we would really want to do sort of at the very beginning here is a little bit of lighting control 101, just to make sure that everybody's on the same page, we're all using the same vocabulary, we all have a good understanding of what it is that we're talking about as we push around some of these terms like daylight zone or occupancy sensing, vacancy sensing, whatever they happen to be. So as a quick primer, these are the typical lighting control strategies that we employ and have employed, frankly, for the last 30 at least years, certainly the 30 years that I've been doing this. Every single one of these strategies has been around for at least that long. Now, some of them are more simple to implement now than they were 30 years ago. For example, astronomic scheduling, which basically means that you note where you happen to be on the Earth, longitude and latitude, and the lighting control system calculates sunrise and sunset to help you control outdoor lighting or campus lighting, things like that. Now, these sorts of systems used to be expensive adjunct controllers. Today, they're basically just a bit of software within every single one of the controllers you can name. So this seems like a big list, but you're looking at a picture of the San Francisco Public Utilities Headquarters Commission down in San Francisco. It's a 14-story urban office building. It admittedly had very high sustainability goals, but it's not unusual with respect to lighting controls. Every single one of these control strategies is used someplace on this building. And that's not, again, an unusual thing. If you're doing an entire building, you're probably going to have all of these. Now, I'm not going to go through necessarily what each of them are, other than occupancy sensing basically means you walk into a space, the lights come on automatically. Vacancy sensing means you walk into a space, you have to press a button in order for the lights to come on. In both cases, the lights will turn off after a certain period of time in which you haven't been in the space. Daylight harvesting simply means when there is sufficient daylight available within an area, an automatic sensor determines that's basically a photocell, usually on the ceiling or slightly outside, and it will modulate the light output of the system accordingly when necessary. And time scheduling, as one would imagine, basically means the lights come on at a certain point, the lights go off at a certain point. There are overrides available for these things. If you want to learn more about these, my Networked Lighting Controls Fundamentals class, a recording of it, is available at the YouTube link that you see there on the screen. Or you can go to the Lighting Design Lab webpage and go to the Education tab and look in the previous classes, and you'll see a variety of different lighting controls options that you can go in and familiarize yourself more with some of these things. But let's make it a little bit more practical. Duane, can we go to the next slide?
Yep.
This is an example that I give in one of my network lighting control classes. This is a fictitious project, TechX offices. Although if you've done any work with any of the big tech companies, this is actually a pretty standard way that they organize themselves into team modules. We would think of this as an office neighborhood, right? So you have a smallish open plan office on the right there. You have a private office upper left, and then you have a small and a medium conference room. Sometimes we call them team rooms or focus rooms, whatever they happen to be. And you'll see that there's a window wall to the right there. So what are the kinds of project strategies that we would employ here? Well, manual dimming, personally, I would like to see manual dimming. People like to have the ability to raise and lower lighting within their spaces. In some of these areas, we would have scene control, so you can press a button and be ready for a presentation or an audio-visual something, or a Zoom call, whatever it happens to be. By code, you're going to need to have occupancy sensing and or vacancy sensing, daylight harvesting within that space because you have a window wall there, and you're probably going to have some kind of time scheduling, or you can take care of the time scheduling function through occupancy or vacancy sensing. Preferably also you're going to have task tuning in there, which basically means modulating the light so that you right size the amount of light based on your needs versus how much the lighting system is delivering at maximum light output. Duane, next slide, please. There we go. So for those who prefer 3D visualizations, this is essentially what those spaces would look like, right? On the upper left, you see a look that is essentially from the doorway into the tech offices there. So your conference room is on the left, the open plan office is on the right. The upper right view is diametrically opposed to that. And then the bottom view is looking into the whole office area from the outside through the window wall. Next slide, please. So if we were talking about a traditional network lighting controls approach, or we might think of this also as a room controller based approach, we would look at it in a manner that's something like this. We'll talk about this a little bit later when we talk about luminaire level lighting controls, how we might see the same thing with luminaire controls. But in this particular case, we might want to have, or we would need to have, two daylighting control zones, right? So what does that mean? To determine your daylight control zone, the area in which you have to control all of the lighting per daylight, you basically take the top of the window, think of that as the window head height, right? So in this case, the window head height, I happen to know, is 9 foot, 9'0", right? So I come in 9 feet into the space, and that describes my primary daylight zone. In this case, it's the zones that are labeled A, C, and C, right? Then I add in my secondary daylight zone because we have to have a primary and secondary daylight zone, which the secondary daylight zone is twice the primary daylight zone, right? So from 0 feet to 9 feet is primary daylight zone. From 9 feet to 18 feet within that space is secondary daylight zone. Those are designated as B and D in this example, right? Now I could have all of them, all of the ones A and C as one zone, but I want to break them up into a more discrete little control zone so that if somebody is working in one area, they don't have to have all of the lights on at once. So in this example, we have a PS, that's a photocell that gives us the daylight control. That dims the primary and secondary daylight zones up and down as required. We have vacancy sensors, VS there. What those basically mean is you walk in, you touch a button on the lighting control station 1 there, the LC1, and lights come on, right? You leave, lights go off. But you have the ability to differentiate within 4 different control zones here what lights you want on. The vacancy sensors will turn the whole group off. Similarly, in the private office, there is a scene control dimmer there with a raise lower and a vacancy sensor. In the 2 conference rooms, the team room and the conference room, we have scene controllers, but we also have vacancy sensors, right? Now we could also do occupancy sensors in these places, but the caveat there is if we were going to have occupancy sensors in these places, they can only be programmed to come to 50% light output initially, right? You can bring the light up higher if you need it, but they can't bring the light on to full light output. Okay, I hope that gives a quick little, sorry, Duane, go ahead.
Sean, I don't think you mentioned what the difference between an aux sensor and a vacancy sensor is.
I did on the last slide, but I can do that again. That's a good call. So if I have an occupancy sensor and I walk into the space, the lights will turn on automatically, right? But they'll only turn on to 50% light output per code because, at least in a place like this, in specialty areas like corridors and stairwells, they can come on to full light output. But in some place like this, they could come on to 50% light output. The vacancy sensor, as I walk in the door, I have to push the on button for all or whatever control zones I want to have illuminated as I walk in. Duane, does that cover, or am I missing something more?
Good. And then my second question is, you've got the one photocell up next to the window, and it's somehow controlling both of those daylight zones separately, the one on the far right and the one on the in the middle?
That is correct. So this is going to depend on what kind of system that you happen to have, right? Some systems require you to have a photocell per control zone, per daylight zone. In this particular case, you actually, or I shouldn't say that, in most cases, most manufacturers now allow you to control multiple daylight zones as long as they're in the same cardinal direction, right? As long as they're still, let's say this is facing east, right? As long as all of the zones that you're controlling are facing east, then you can control the primary and secondary daylight zone from one sensor. Effectively, what it will do is do a little bit of percentage algorithm so that the primary daylight zone will dim by a certain percentage. The secondary daylight zone will dim by another percentage, right? So essentially you have deeper dimming closer to the window, you have less dimming a little bit further from the window. That's how actually a lot of systems are set up and configured. We'll talk more about luminaire level lighting controls and individual fixture control a little bit later. One thing I do want to mention, though, we're not going to go into this in any depth, is that any of these control systems, you need to pay attention to your sequence of operations. It's not enough to simply say, I've got a bunch of hardware and that's great. You need to sort of think through as designers or implementers or installers, what is the system supposed to do? There are a lot of different ways to document that, right? This happens to be one that I like, which is a matrix that is associated with sheet notes that goes on to a drawing set in a contract set. But you can also do narratives, you can also do CSI spec documentation. However you do it, somebody needs to come up with, during the design phase, a real detailed look at how the system is supposed to work in order for it to actually function the way it's supposed to. So, Duane, I think that's it for me. So back to you.
So we have it in the code, in the control section, a long list of additional lighting controls, and most of them just mean that they have to be separately switched. So if you got display lighting, display cases, jewelry cases, desk lights, plant lights, any of these things have to be separately switched from your actual room lighting. There are some specific rules we can get into regarding hotel rooms, which are called sleeping units in the code, and dwelling units themselves have are an entirely different universe that really under this code require almost no control at all. The exit access is one thing I mentioned a little earlier that we set up for other rules. We set up emergency lighting circuits so that if there's a power failure, certain lights will turn on, and it used to be that people just left those on in perpetuity, which is why the downtown towers always had that glow going all night long. But the rules now say that no, when the main room lights are off, those exit access lights are on, and they will come on automatically if there is a power failure in some emergency later. In the emergency exits, you've got to have those have to be fed with the same power as everything else, and then when there's an emergency, it switches over onto those. And this is all made possible now because of UL 924 controllers that are allowed. And Sean, do you want to tell them what a 924 compliant device is?
Yeah, so to again make this a little practical, this is a photograph from a trip that I took, gosh, many years ago now. This is a Spokane Public Library, and the lighting, of course, in this photograph is fluorescent. If we would do it as LED, but you'll notice that it's a beautifully daylighted space, and of course, all of the lighting is off except these individual, quote, emergency egress, whatever they want to call them in this particular case, which are 24-hour circuit, as Duane is mentioning. Most codes now, and in fact, the general design preference is to control your egress emergency exit lighting with the general lighting when it is part of the architectural lighting. Now, this used to be difficult and cumbersome. We used to have to require extremely expensive things like UL 1008 devices, and I'm not going to go into all of that sort of stuff. Generally speaking, today, however, you've got a few different options, right? You might have a generator that's feeding emergency circuits, so there might be a transfer switch that when you lose normal power, the generator kicks in and the emergency circuits drive to full, and that's how they're controlled. You might have an inverter system doing a very similar kind of a thing with batteries, or you might have battery backup within each luminaire, like a Bodine battery pack or something. However that works, the preference and in fact somewhat requirement is that you need to be able to, frankly, turn the lights off. There needs to be a way to turn the lights off, preferably to be able to dim them along with everything else. One of the easiest ways to do that now is with the advent of UL 924 devices. Can we go to the next slide? This will be an example of one of the teaching boards that I've developed for my networked lighting controls classes. So what we have here is on the right side there, we've got a pair of controls, a pair of loads, right? So the two light fixtures represent basically corridor lighting, right? The one on the top represents the emergency lighting in the corridor. The one on the bottom represents the normal lighting in the corridor. So if we go ahead and, Duane, you're gonna have to click to play the video. There you go. So if you'll notice, I just hit on and all the lights came on, right? I just hit off and all the lights went off. Now I'm going to show you that dimming. So the lights are on, now I'm dimming it all together, right? So the emergency is being controlled very much with the normal lighting. However, we're about to have a power outage for the normal lighting, the normal power. So normal power went out, and you'll notice that the emergency circuit through this UL 924 contactor immediately went to full light output. Once the normal power was restored, we actually had the ability to then control the lighting once more, right? So I hope this sort of makes a little sense for you guys. Basically, today, you can either have UL 924 controllers, we call them as shunt relays. You'll see the device that's on the top in the junction box on the top it's actually a third-party relay that is taking feed from both normal power and from the emergency feed. That emergency feed could come from a generator, could come from an inverter, however that happens to be. And then when it senses the loss of normal power, it immediately engages and drives the load to full. Now, there are also a number of lighting control systems these days, the parts and pieces sort of network lighting control systems that actually offer standard load controllers. That green device that you see in the bottom is what we call a load controller, right? That's a device that has a relay in it to turn the lights on and off. It also provides the 0 to 10 volt dimming signal for the light fixtures, right? That can control one light as it is in this case, or it can control a whole bunch of lights, however it wants to get configured. That device can be configured for normal power, or it can also be its own UL 924 device. So it has a sensing mechanism. It is fed by a different circuit that is then fed either by a generator governed circuit or an inverter governed circuit, and allows to go to full light output. So however you do it, it's not complicated anymore to go ahead and do this kind of control. It really is not. All right, Duane, back to you.
Okay, going outdoors for a moment. I was just noticing that outdoors here in Seattle is a pretty nice day for a change. We want to make sure that things are off when it's daylight, of course, and then we require that for facade lighting and landscape lighting, midnight to 6, it turns off. Then there's the all other, which would include parking lot lighting and walkways and a number of other things, which they need to be reduced at least 30% midnight to 6, or another kind of hours if you have odd operating hours for your business, or if they're on some kind of occupancy sensor and there hasn't been any activity for 15 minutes. I just love photographs like this, because here you got all the lights in this huge parking lot blazing, and there's 3 cars there. That's probably the 2 cleaning people and security guard, and those just stay on all the time. It actually ends up being, I think, a little less safe, because if you had it on some kind of occupancy sensor, then at least you'd see lights turn off and then turn back on when somebody started walking into the space, and it would alert you something was going on. Anyway, Sean, you wanted to talk about wireless controls, right?
Yeah, just throw in one thing for you, that when we're talking about exterior lighting controls, expect more and more this to be the case, that we are going to be expecting a lot of the control strategies that we use indoors to move outdoors, particularly things like dimming, right? We have light fixtures that are easily dimmable. Let's make use of them. So as Duane's mentioning, different types of time use. Maybe we have parking lots that, they start at full light output when we're 6 o'clock at night or whenever sunset is. And then over time, as the use fades, but also as our eyes become better adapted to nighttime, maybe that light level starts to dim down and down and down, so that at a certain point, we're down pretty far. We're harvesting a lot of energy savings. And the way to do that commonly these days is going to be with wireless controls, just like we do indoors. So that might be Bluetooth low energy, that might be Bluetooth mesh, that might be something else, however we configure them. But just assume that we are going to be seeing occupancy sensing, an astronomic time clock, task tuning, all of these things becoming the norm for exterior lighting, for not just parking lots, but also for things like pathways on campuses and pedestrian lighting. So expect that to be in the future. Some of it's here.
So Sean, say it's foggy or it's snowing or something else. Are these going to dependably work all the time when you need the light?
That's an excellent question. I'm going to tell you that for some technologies, in particular, the occupancy sensing, it's not going to be perfect at this point yet. So as I say, that's why these things are in a certain extent coming. So a typical passive infrared occupancy sensor that we would use indoors, they do have them for outdoor uses, but they're not as accurate, if you will, for some of the reasons that you're talking about. Also, imagine, you've got, you're essentially looking for movement of background infrared. Well, the human body is 98.6, right? We had some 98-degree days this summer, right? So if the human body is similar to the background radiance of the space, it's not going to catch you. Now, there are advances in microwaves and LiDAR and a variety of other things. I'm going to tell you that probably within the next 4 to 5 years, I would be shocked if they didn't have the outdoor occupancy sensor challenge licked.
Okay, we'll be looking forward to that. So we just spent the last 20 minutes talking about controls, and now we're talking about lighting power. We mentioned it a little bit early on in just that it's been quite a ride as we've gotten onto newer technologies. So Washington State, we brought down from the 2015 code to the 2018 code that went into effect this year. We brought lighting levels or lighting power allowances down 11%. This aligned with the ASHRAE 90.1 research project, which rejiggered a lot of these room lighting levels. What was interesting was that there were 20 different room types, most of them very small rooms, that got larger lighting power allowances. like nurse stations and food prep areas, like a number of things where they realize that you just need more. I think it's hard to get down that low when you've got a small or oddly configured space. Then Seattle brought those state lighting power allowances down 10% below the Washington levels, like they were below the 2015 code level. I do keep checking in with our electric review staff, and it's really rare that anybody has a problem meeting those levels. I think they told me that once last year there was a hotel lobby that somebody wanted to load up with some amazing amount of lighting that didn't pass, but it's quite unusual. Then in the table of lighting power allowances, there's a long list of footnotes, and just wanted to highlight some of them that are new or changed. That MNOP are from the California code, giving some extra for whiteboard. I guess no one uses a chalkboard anymore. That for those rooms you see there, banking, break room, stairwell, etc. A little 0.3 watts a square foot for ornamental lighting. Actually, that's not little, because if you think that lots of rooms have 0.6 or 0.8, that's quite a big boost. That kind of just means anything that's not general lighting. Labs got something for under shelf lighting typically, and offices for things that come with your office landscape stuff. We did, at the request of some local lighting designers, added some extra for display and decorative lighting in corridors, and that came up from the hotel corridor problem, that with that shape of a space and their need to have some kind of a nice sconce fixture at each wall, they just needed that extra little bit. And then finally, if you're going to go for germicidal lighting, I think the jury's still kind of out about exactly how much good that's going to do. That doesn't have to be counted in the total amount. So, office example, Sean.
Thanks, Duane. So Duane, when Duane and I were talking about putting this class together back in December of last year, we decided that it would be really good to have a number of practical examples, right? We can talk about numbers all day long, but it's good to continue with some of these practical examples. Before I dive into that, however, I do want to remind everybody, if you have any questions, please go ahead and put them into the questions box that you'll find in the GoToWebinar interface. Haven't seen any yet, which is okay. It's fine if we're fantastic presenters and you don't have any questions, but if you do, please feel free. All right, so let's dive into some practical examples here. This is an office. This is a tech office open plan, which might look suspiciously like the example that I gave you earlier for Tech Project X, because it's very similar, right? A lot of these corporate software companies, as I mentioned, organize themselves into office neighborhoods like this. So this is an open plan office, relatively small, daylight window wall there. It was a renovation of an existing building that we completed just a couple years ago, 2016 it was, in fact. So of course, all the lighting is LED, all the lighting is controllable, all these things. If we were designing this with today's Seattle Energy Code, our allowable lighting power density, LPD, would be 0.55 watts per square foot, right? If we take a look at the actual installed project, what we see is 0.42 watts per square foot. Now, our target light level is 25 foot candles in that space, and measured average is about 30 foot candles. We have occupancy sensing, daylight harvesting, task tuning, all of these things. So essentially, this exceeded the requirements of today's Seattle Energy Code in 2016, 5 years ago, right? So this is just giving you some example. Now, I want to be clear that one of the key things about energy code spaces is that they're tradable, right? This is an open plan office. I might be under here, but on the same project, if I'm doing a big project, I might have a lounge where I need to have more decorative. I need to have a little bit of extra light in there, so I can trade power allowances back and forth. So I don't want to say for you designers out there that this is an incredibly easy thing. It's not, but it is possible. It is absolutely possible to meet today's energy code. Can we go to the next slide, Duane? This is another example. So when it comes up, I wanted to think about classrooms, but I wanted to think about sort of fairly archetypical classrooms that we could think through in a couple of different ways. This is actually a laboratory classroom from the North Seattle Community College, or sorry, North Seattle College, the Allied Health Tech building, right? So this was done actually in, I think it was finished probably in 2012, maybe 2011. So I want to be clear, all the lighting that you're seeing in this image is fluorescent. As a thought exercise, what I wanted to kind of do was think about, well, if I was going to design this today with the exact same design scenario, right? The first example showed you recessed linear lighting in the ceiling. This is showing you indirect direct lighting with some wall washing at the whiteboard there. So if I looked at this today, right, and you'll see that the drawing that you have there corresponds directly to the photograph that's up above it, we would have an allowed 0.64 watts per square foot plus an additional 4.5 watts per linear foot for the whiteboard up at the front, right? So going through the numbers, we would have an overall allowance of about 953 watts for this particular space. Great. Looking through this, we've got general area lighting. If we're doing this with LED to get to the same light level, we're looking at 720 watts. We have a bit more for the perimeter of 120 watts, 90 at the whiteboard. So the proposed lighting would be 930 watts, which would be under the current energy code, right? We would have occupancy sensing, scene control, daylight harvesting, all of those things in here. In fact, we have them in the fluorescent mode as well, and everything is dimmable. So this is an example of going from fluorescent, how we would have thought about the same space. Original design with fluorescent, new design would be LED. What if we thought about this a little bit differently though, right? This is thinking about this as if it's a basic classroom. So if it was a basic classroom, we're beating the energy code by 23 watts, but it's not a basic classroom. Can we go to the next slide? It's actually a lab classroom, right? We're going to have lab functions in here. So we actually have an allowed lighting power density under the code of 1.0 watt per square foot. So if we've done nothing to change it, right, we still have terrific lighting in here. It's all dimmable. It's indirect, direct. We have wall washing on the board. We have light levels commensurate with using a lab classroom. We're still at the proposed 930 watts, but our allowance went up to 1420 watts. So it's actually, from my perspective, not hugely difficult to meet. It requires some thought, it requires some, maybe some trading, maybe some additional thought, but meeting these energy codes is not that difficult. Can we go to the next slide, Duane? Another key one is the notion of corridors, right? One of the additions that Duane had talked about was adding 0.25 watts per square foot for display and decorative corridor lighting, while the allowed power density has dropped down to 0.37 watts per square foot. Duane, I'm recalling, was that 0.4 watts in the previous example, previous code, I think?
I can't remember. Sorry.
Yeah, mine's like a stainless steel sieve sometimes, sorry. So this is a very atypical example, right? This is Tommy Bahama's headquarters right here in Seattle. Who knew Tommy Bahama was headquartered in Seattle, right? You'll notice that a lot of the lighting is decorative, either accent lighting or in the case of the pendants there, those are meant to be decorative pendants, right, within that space. So one of the interesting things about this, of course, is that we are definitely making use of the 0.25 watts per square foot for display lighting and decorative. So in this snippet of this corridor, and it is only a snippet, 1,671 square feet, sorry, we have an initial allowance of 618 watts, an additional allowance with the display lighting of 417 watts, for a total of 1,035 watts. Now the installed, what we've got here, the installed lighting that you see in this plan represents 820 watts. So we still have, particularly given this allowance for decorative display lighting, we have some ability to still do a very good lighting project while being very high performance, right, as well. Can we go to the next one?
Yeah, and that was 0.48 actually in the previous code.
Okay.
Dropped by a quarter.
Okay. A slightly more prosaic example, right? That was a high-end office corridor that you're going to see, really, lots of display, all these things. What about a typical multifamily corridor, right? This is actually an excellent example that the Lighting Research Center put together last year, part of their LRC Delta snapshots. You can download the whole thing from the link that I have there at the bottom. And essentially what they did was looked at two public housing facilities in upstate New York, and they replaced the lighting, I think it was 1 for 1. If not, it was close to 1 for 1, swapping out fluorescent for LED. They did make some changes. So you'll see in the image here, before the light fixtures were transverse to the corridor, now they're parallel to the corridor, kicking more light up onto the walls. And they actually did increase the light level, right? Previously, it had been 100 lux, about 10-foot candles, and they've increased it to about 30-foot candles, which honestly is brighter than I would do for a corridor, right? But for their example, it's fine. What they came up with was a lighting power density of about 0.38 watts per square foot. So they're over by 0.01, but they've tripled the light output. So imagine if they only doubled the light output, where they would be. Now, they added luminaire level lighting controls. So as Duane mentioned earlier, basically what this means is that you have the light fixture and all of the dimming components and sensors right in the light fixture itself. So you wind up dimming the light fixtures down to 20% light output when it doesn't see anybody in the corridor. As soon as it sees somebody, it dims back up to the target light level, whatever that happens to be. And this is a fantastic renovation, right? They've replaced them 1 for 1. There's no rewiring required. All of the controls are within the light fixtures themselves, so simple, easy peasy. You've got basically 3 wires to connect, a hot, a neutral, and a ground, and you're off to the races. Now, this resulted in some amazing control savings. Duane, can we go to the next one? So one of the things that's most interesting about this project to me is that 78% of the people there loved the bi-level lighting, right? It worked out just fine for them. You want to be careful in corridors. If you turn the lights to off and then have the occupancy sensing, that becomes disturbing for people. They don't like it. They're going to wind up trying to figure out how to defeat the system. If you wind up giving it to 20%, you're still harvesting 75% of the energy savings while not irritating people. But look at these energy savings that they've got in here, right? 33% savings just going to the LED light fixtures with the increased light level, but 73% savings when you actually add in the lighting controls. That's huge. One of the key things here too is the idea that they put the timeout as 5 minutes. Now, a lot of times I still hear people saying that timeouts on occupancy sensors should be 30 minutes. The reason that we standardized as an industry to 30 minutes for occupancy sensors had nothing to do with human perception, had nothing to do with energy savings, had everything to do with fluorescent lamps, right? We didn't want to be switching fluorescent lamps on and off too often so that we weren't shortening the lamp life too significantly during the controls. Well, LEDs like being turned on and off. They have no problem with that. So going to shorter timeouts, experiment with it, 5 minutes, 15 minutes. 15 minutes, I think, Duane, correct me if I'm wrong, is the current code requirement, right?
That's what the setting is for Seattle, yeah.
Okay. Personally, I'd go to 5, but that's just me. So, I mean, this just gives you some sense of what is possible out there within the bounds. And again, this is all within the bounds of the current code. Huge improvements. One final word. Can we go to the next slide?
Yeah, and if you can remain perfectly still in a corridor for 5 minutes, then you're probably in a state that does not require lighting at the moment. I just want to mention I was in a hotel in London that had a 15-second timeout, and so when you open the door to your room into the corridor, you open it into a dark corridor, and then like a second later, the lights would blink on. So I think that the 20% makes people feel like they can look out the little peephole in their door and see the corridor there. So comforting in some way.
Yep. So the last bit here to think about, Duane had mentioned germicidal ultraviolet as being exempt from the code. Just a quick thought for those of you who you might have noticed there's some spiky virus going around. Using germicidal ultraviolet as a means of disinfecting surfaces has been around since at least the 19th century. We use this for water, for upper air surfaces, tuberculosis wards, all these kinds of things. If you want to learn more about this, there is a whole lot of questionable information out there right now. It is possible to do. It is not quite the panacea necessarily. It's also challenging, both physiologically and in other ways. So if you want to learn more about this, go to the IES links that are there, and there are some terrific information about GUV to be found there. Or ping me later, and I'll be glad to talk to you about it. All right, back to you, Duane.
So Seattle's favorite horticultural crop. If you look at my little sketch diagram on the bottom, our visible light perception that we humans use, centers around that green, yellow, orange area there, and that's what we figure what kind of lighting we're getting. Plants don't see the world that way. They have that other sort of bimodal curve that is really more interested in those areas outside of our visible range. And so we have a different metric that measures that light that plants see, and it's measured in micromoles per joule. Following rulemaking in California, where they did a lot of research on this. Okay, one in the warehouse type that is most of our indoor growing here in Washington State, 1.9 micromoles per joule allows for LED and for double-ended HID because some of the growers just insist that results in a better product. But we don't use lumens for this because lumens are for humans. For Seattle, we've mentioned that large open office needs LLLC, and that we're going to dive into here in a little bit. You can use LLLC for these large open office areas, or since I got complaints from lighting designers that the range of fixture types that are available with LLLC controls is kind of just includes the plain potatoes ones, and for higher end properties, they really wanted a network lighting control system, which has something to do with this diagram that you see on the right. But I'll let the actual expert dive into this deeper.
Thanks, Duane. Yeah, folks, we've been talking a little bit about LLCs. That just rolls off the tongue, doesn't it? Luminaire level lighting controls. We've talked about them a little bit. Let's deep dive for a couple of moments. What are luminaire level lighting controls? So we have the idea of network lighting controls, right? We have devices that communicate with each other either wirelessly or through data wire, however that happens to be, in which we have light fixtures, wall stations, controllers, occupancy, vacancy, daylight sensors up in the ceiling. One of the ways this has been described is as a single control to many devices, right? That's one way to think about it. So that's a network lighting control approach. Luminaire level lighting controls is a subset of that. Basically what that means is you take the load controller, you take the occupancy sensor, vacancy sensor, daylight sensor, and put it all into one package within the light fixture. And it operates essentially as its own little lighting control system. Normally speaking, these are networked together so they communicate to each other, and then they communicate to a larger system so that you can do scheduling and task tuning and all of these other great things, and you can press wall station buttons and have them come up, come down, dim, all these things. But essentially the idea is it brings everything together. So one of the key reasons that we like these is that they're frankly easy to install and easy to specify. You know, one of the things that I see that people have trouble with is developing control zones, right? What light fixtures want to control, want to dim up and down together. Well, if they're all their individual unique control zones, you don't have to worry about that anymore. You don't have to worry about wiring to these things because basically, again, you throw them up in the ceiling, there are 3 connections, a hot, a neutral, and a ground, and you're done. So there are a lot of reasons for this kind of a thing. Now, we used to think of them as vertically integrated lighting systems. So some of you that have been around a while might remember things like Light Ergolite system, or Lightalier took that over at one point. But there are a number of different ways to think about this. But it's really the same thing. The difference between those systems and today's luminaire level lighting controls is that today's systems actually work. Right? We don't have the hassles that we used to have with, let's face it, the Ergolite was a terrific product for its day, but it never really worked very well, and it didn't coordinate with the other lighting controls in the space. So can we bump to the next slide, please? So let's look at, before we do that, so there are some considerations and a variety of different things. You'll notice that in the handouts, I have given you this document. I've also given you the Lighting Design Labs LLLC, NLC guide series as a PDF. And I've also given you 2 studies. One study that both done for NEA, Northwest Energy Efficiency Alliance, one looking at 1-for-1 replacement of network lighting controls versus LLLC, and the other looking at LLLC potential savings. But there are some key things on this slide that I do want to highlight before we move on to looking at the actual approach. One of them is the cost. Typically, you're going to see an upcharge of somewhere between $35 and $75 per luminaire for luminaire level lighting controls over fixtures that are not similarly equipped. Now that seems like a lot of money, doesn't it? Think about how much savings you have from a design standpoint, how much savings you have from an installation standpoint, how much savings you have from an energy code standpoint, because you don't have to exhaustively document the energy controls for the energy code with LLC in most cases. You basically just say, I've got LLC, and that's good enough because they meet code basically right out of the box, right? So another thing to consider here is that many of the utilities throughout the Pacific Northwest, certainly Seattle City Light and Puget Sound Energy, offer incentives to go ahead and upgrade to these things. In the case of Seattle City Light, for example, networked and or luminaire level lighting controls will give you a $50 per light fixture kicker in your retrofit budget, which basically covers the cost of the controls in most cases. So terrific things to do. If you have questions about those, contact me directly, or we talk a lot about these in the network lighting controls class. Duane, can we bump to the next one?
Yeah, and did you say that the savings in those control legs of wiring and the other controls you'd have to put in would cover the additional cost of the luminaires?
It depends on the specific system. It depends, like everything else, on the details. You know what Mies van der Rohe said about details. For those who don't, God is in the details. So the reality, however, is that in many cases, yes, since they are so easy to deal with, if you are doing a one-for-one replacement, you throw them up in the ceiling, they have some level of programming straight out of the box, super, super, super simple. No real thought or planning required. Really, really cool. So let me go back to our tech offices here. I showed you the way that we would think about the lighting control zoning with respect to the traditional network lighting control approach. If we were doing luminaire level lighting control approach here, you'll notice that instead of having 4 control zones within the open office, we actually have 8, right? Because each individual fixture is its own control zone. You'll notice that we lost the the vacancy sensors and the photocell from the from the open plan office. Why is that? Well, because each one of the fixtures has its own sensor in it, right? Now, if you go to the private office, you'll see a similar thing, right? You no longer have a vacancy sensor there because the sensors are in the light fixtures themselves. You have extended functionality, not just the same functionality. You actually have more control than you had before. But notice in the team room and the conference room, we still have the vacancy sensors that we had before, because as Duane mentioned, not every light fixture available can have a sensor associated with it, right? The wall washers don't, the decorative fixtures don't. So we have here one system, one networked control system within which all of the fixtures that can be LLLC are LLLC, but it all works together seamlessly. This is the real benefit from my perspective, right? Pick and choose what works best for the specific space. All right, can we go to the next slide? Is a good example here, and this is actually a few years old now, 2015, 6 years old. Some of you will remember Michael Lane. Michael Lane was a venerable alum of the Lighting Design Lab for many years. He is now in charge of a lot of the lighting and lighting control stuff over at Puget Sound Energy. So they did a pilot study in 2015 looking at LLC. And basically what they did was replace their existing parabolic T8 light fixtures with LED-based light fixtures that were dimmable, and LLLC that included occupancy sensing, daylight harvesting, and task tuning, right? So they wound up with a 35% energy savings with just the light fixtures, right? This mirrors a little bit what we were looking at with the study that LRC had put together. But when they added in the sensing and the occupancy and daylight sensing abilities of the LLC system, they saw a 72% energy savings, right? And they had very happy staff because they had much better control. They had the ability to raise and load, dim and dim up and dim down the light fixtures when they needed to. If you want to see the actual study itself, go ahead and take a look at the link that I have at the bottom there. You'll be able to see a lot of information. But this is just one of many examples proving out how useful this technology really is. Next slide, Duane.
And note that most CEOs don't care at all about their energy bills, but they really care about staff happiness.
Yeah, if you can raise productivity by only, what was it, 3%, maybe even less than that now. You actually pay for the entire capital cost of each employee's workstation, not the lighting, the entire capital cost. That's the way that works out. This is the redesign study that I have posted for you here. Nia did this at a test bed down at the University of Oregon with Kevin Vanden Wy-Mellenberg, some of you may know, who is also a lighting design lab, day lighting lab alum. And they found with replacement 50 to 74% energy savings versus redesign of 59% energy savings. So lots of good stuff there. Again, the whole study is available for you to look at. And if we go to the next slide. I have given you our network lighting control guide sheets here, but if you go to the Lighting Design Lab webpage and browse around, you'll find that there's a lot more information there as well, including some really handy videos that bring you through this whole idea of network lighting control versus LLC and how they work together. All right, Duane, back to you.
Okay, we'll leave lighting for a bit here and talk about some electrical issues. Dwelling units in Seattle, if you've got, meaning apartments, right? If you've got gas cooktop or in-unit gas water heater or dryer, each of those has to have a fully functioning, properly sized electrical outlet right there, so that literally changing from fossil fuel to electric in the future would be just plug and play. Controlled receptacles have taken a while to kind of get moving here in Seattle, even though it's been in the last, I don't know, 3 energy codes. It asks for half of the outlets in those listed space types there to be controlled, so that either with an occupancy sensor or an automatic time clock, these will turn off. If you look at those 3 diagrams, I think this is from Rocky Mountain Institute, maybe. You start out with that big circle, that's all our energy use, then you do a really good job reducing all the other HVAC and lighting and water heating loads. The circle gets smaller, but proportionally plug loads get bigger. And in Seattle and in California, commercial buildings are approaching something like 50% of the load being plug loads. So we got to do something, and this is our thing, since we can't control the actual stuff that people do plug in. So you got an outlet, a duplex outlet. You can have the top half on the time clock turning off on the weekends or when nobody's there, and the bottom half uncontrolled. So that's where you plug in, your computer or your classroom aquarium or whatever. Or if you don't want to do the split receptacles, just the controlled has to be within a foot of the uncontrolled ones. I should say that a lot of offices now are using those adjustable height workstations, and those just have kind of a single set of outlets attached to them, and so people will plug those into the non-controlled outlets, but we'll deal with that as time goes on. A lot of stuff it gets plugged in and keeps pulling energy, even when they don't look like they're doing anything. I think that a typical base load, that level of electric use below which the building never ever goes, is about 20% of peak load, and that 20% is running for 8,760 hours a year instead of just a couple thousand. So you can get quite a bit. I don't know if I told you the microwave example. If you've got a microwave, 1,000-watt microwave oven that typically runs 6 minutes a day, say, some days not at all and some days more, whatever. That little LED clock up in the corner will use as much energy per year as the actual microwaving. So a lot of stuff going on there with things that look like they're off. Back to you, Sean, I think.
Yeah, and actually, I mean, one of the things about the vampire plug loads, it's funny to have to think about this, but some of you will know that before coming back to the lab, my last gig was running Luma lighting for PAE engineers out of the Bullitt Center. PAE did a lot of work with respect to plug loads and the Bullitt Center. Of course, PAE was the engineer for the Bullitt Center. Those of you who don't know, up on Capitol Hill, once this corona is over, please go ahead and take a tour of the building if you haven't already. Fantastic example of forward-thinking, sustainable design, right? So one of the key things is that the building is meant to be net energy positive. That doesn't mean it's not connected to the grid. It does mean that it's supposed to generate more energy than it uses. So since plug loads are a big thing, PAE actually spent the time to do an inventory of all of the devices at the office in Portland, in fact, and go through and figure out what were those vampire loads, which ones could be turned off overnight, which ones couldn't, and in many cases, were there alternatives available for that would do the same thing, but would use less cost. So what we basically have here is that they were looking at I think it was a 19%, yeah, there it is, 19% energy use in a building for plug loads. And by doing an inventory, by really paying attention, they were able to drive that down to 11%. 8% is actually a fairly significant number for any building. So pay attention to those things. And then again, of course, as Duane mentioned, one of the things that people usually complain about is with these switchable outlets is, oh my God, I lost work on my CPU. They are labeled. They have to be labeled by code. Don't plug your CPU into one that's controlled, and you'll be fine. Won't be a problem. Okay, back to you, Duane.
So we have the C406 section, which requires that every project do a certain number of things that are above energy code, and you get to pick from a menu of a dozen items. I've circled on the top some of those that are germane to today's discussion, and really a lot of what we're doing is to try to move other things that are using fossil fuels over into all electric. But in Washington State, you need to get 6 credits from this list, and in Seattle, since we're cooler than everybody, we've bumped it up to 8 credits total. So you're looking Group E education. You can see on that second level down where it's 2 credits. That is 2 credits that you get of the 8 that you need from reducing your lighting power by just 10%. Okay. So I think this would be you again, Sean.
Yeah. So jumping back to that, just one of the things that we want to make sure that it's clear that these are attainable goals, right? These are not just pie in the sky things. Looking at the stuff that we've talked about today, the major software company example that we looked at exceeded code by 24%. Tommy Bahama's corridor exceeded by 21%. The lab classroom we saw exceeded by 35%. Now, it's not always going to be possible to meet some of these goals to exceed code, but it can be done, right? So don't shy away from the opportunity if you are really trying to have a high performance building. You can do this and still maintain high performance lighting goals at the same time. Next slide, please, Duane. We decided we'd give you a quick couple of examples further along here. So just a quick look. This is Miller Hull Studios. So Miller Hull is, of course, an iconic Seattle architecture firm. A few years ago, I redesigned the lighting for and with them. They occupy the top floor of the Polson building in Pioneer Square, right? So it's the top floor of an old, used to be unreinforced masonry. Hopefully it's been retrofitted. It has been retrofitted building. Duane, I think were you at a NBBJ the day of the earthquake too?
Yes, good time.
And anyway, different story, folks. So it's about 14,000 square feet. It was a TI renovation. We completed it in 2017. So can you go to the next slide?
Yep.
The original lighting for it was all linear fluorescent. It had been done in the late 80s. Come on. You can do it. There we go. It had been done in the late 80s. And basically, for the time, it actually was pretty okay, right? It was fluorescent. It was, I think, 1.14 watts per square foot, which for the day was actually quite good. It was indirect direct. The biggest problem with it was that it had precisely one control zone. You walked onto the floor, you wanted to do some work, you were one person there on a Sunday, the entire floor plate had to be lighted up. So when we redid the lighting, we put in dimmable LED with essentially, it's not actually LLC, but it might as well be, because each one of the major light fixtures is its own control zone. They just don't have the sensors in them. As Duane had mentioned, you can't get sensors in every light fixture. So ultimately, better lighting control, a happier staff. We've gone from 1.14 watts per square foot to a power density of 0.3 watts per square foot. Right now, this is a building that has lots of daylight. It also is a building that has a population that's motivated to save energy, but it's 60% better than code. Now, when you add in the lighting controls to it, the effective lighting power density drops to something like 0.15 watts per square foot, right? Why don't we go to the next one, Duane? Just give you a couple of.
So you'll be getting, since you're more than 20% better than code, you'll be qualifying for 4 of the 8 credits needed in Seattle, and if you're a lighting or electrical consultant, that can make you a hero with the design team.
Lighting designers are always the heroes of the design team, Duane.
Yeah, I know.
So just wanted to give a couple of other quick examples here about ways that you could potentially do this, right? This is a more typical, this might be like a K-12 classroom with a south-facing window wall there, right? If we were using very typical, 2x2 LED light fixtures and a linear wall washer at the front, we might have an allowed power density of 0.64 watts per square foot with the additional 4.5 now watts per linear foot for the window wall, for a total of 684 watts. Now, if our target light level is 30 foot candles, right? In this case, the estimated light level is 36 foot candles. And before anyone asks, yes, we meet the OSPI standards here. So the proposed is 414 watts. We're exceeding code by 40%. Let's go to the next one. If we bump the ceiling a little bit higher from 8 foot and we go up to, 10 foot? 10 foot. That allows us to go ahead and use indirect direct rather than just recessed. Well, okay, let's look at what that might look like. In this particular case, we have a target light level, same, estimated light level of 35. Our proposed wattage is 450 watts. So we're exceeding code only by 35%. And we've gone down, we're still exceeding code by an enormous amount. And from my perspective, providing a better quality of light. Can we go to the next one? Okay, just another real quick case study. So similar to the Miller Hull, I just wanted to give you a little bit more information. This is my old office up in the Bullitt Center. we occupy the third floor in the Bullitt Center. It's about 6,100 square feet. We did a TI renovation when we moved down from the sixth floor to take over the third floor in 2017. Next slide. Yeah, this is getting slow. Okay, so just a quick look at the lighting layout. Of course, you know, being in the Bullitt Center and also being a very forward-thinking lighting firm, everything is high performance LED, and the original design called for very, very high performance lighting controls, including dimming, task tuning, vacancy censoring, all of these different things. Now, one thing that I will say is that I intentionally overlighted the space so that I could task tune it back. Why did I do that? Because I wanted to enforce a longer lifespan on the light fixtures. If I dim down an LED light fixture, that is potentially extending the usable life of that light fixture, right? So our actual proposed budget here was 0.58 watts per square foot. Now, I think at the time, our energy allowance was about 0.9 watts per square foot, so we were still significantly under that. Right now, we're talking about 0.55 watts, right? So this would actually be above that, in part because we are planning to task tune it down significantly. So let's go to the next slide. I made a key error. While this was under construction, I went away on my honeymoon for 3 weeks, and a value engineering proposal was accepted without my knowledge. So that value engineering proposal was all about the lighting controls. So instead of the high performance lighting controls we designed, we were provided with lighting controls that frankly didn't actually meet code. There was literally no way to turn the lights off. In the world's most sustainable then building, that was a real problem, right? It was literally not possible to turn those two light fixtures off you see there, because when you turn the lights off, those would bump on because those were, quote, emergency lights, right? So yes, a few dollars were saved, but it really just became a running unfortunate joke. Long story short, next slide, please. We did a retrofit. One of the lighting controls manufacturers came to us and said, we'd like to use you as a beta test site. Great, we did it. So what we wound up doing was retrofitting all of our lighting. We used a parts and pieces approach with a standard, this is actually a budget network lighting control system here. Nothing special about this system. I use 8 or 9 of them in my classes, my network lighting controls classes, that could all do the exact same thing. We added in load controllers to make each individual light fixture dimmable. We added in occupancy sensors that overlapped control zones. We added daylight sensors, everything. We did all these things. Task tuning. I was able to task tune the light fixtures so they provided the light level that I wanted while also being frankly less glary. This is another benefit of task tuning. So all these things kind of came together. Next slide, please. The best benefit was frankly that we could turn the lights off. This was delightful because this is also one of the best daylighted buildings that you're going to find. There we go. So I can't tell you how happy the staff was that even in this conference room, previously we had not been able to turn the lights off. You turn the lights off and one of the 4 would always stay on. It was very unfortunate. But we also gave staff the ability to raise and lower lighting according to their own particular needs. People like to have control of their environment. Next slide, please. So best thing about this, as I mentioned, is that we could turn the lights off. We also had specific control of the lights. In this particular case, you see Tony here working on a Sunday afternoon as I'm taking photographs. There are 2 lights on for him. There are 2 lights on for Mitria down at the end there, who was working on something else in the building, but everything else was turned off, right? We didn't have that whole everything on that we'd had with the value engineer. So effectively, our effective lighting power density dropped to 0.15 watts per square foot annualized. And we had the meter data. This is one of the most highly metered buildings on the planet. We had the data to prove that this was true. So we had more than a 70% effective reduction over baseline, and we did it for what would effectively have been about 0.78 cents per square foot at a retail cost, right? Not a project level cost, but the equipment at a retail. If I bought it on Amazon.com, it would cost 78 cents per square foot. So that'll give you some quick thing about some of the cost effectiveness of how to deal with some of these lighting control issues. I'll leave you with lighting controls with the idea that lighting controls are better, cheaper, more effective, more simplified than they have ever been before. Don't be scared by them. Duane, back to you. I think we're going to solar.
All right. Yeah, we'll hop and skip through solar here. In Seattle, you've got to get you've got to provide a quarter of a watt per square foot of building area of renewable, which typically this is going to be PV. What I've X'd out on the right side is the way the state code handles this, which is that you have to calculate the annual solar energy production, and then it's different for every building type, and that just seemed a little bit silly. So in this code, you just got to have this quarter of a watt per square foot, or to get 3 credits, or you could have 2/3 of that and get 2 credits, or 1/3 of it and get 1 credit. That would also be allowable. We had in the previous code had a 0.07 watts per square foot, and it just ended up being a lot of money per watt because it was a small system. So we went up to the 0.25 watts, which is more than 3 times as much, but it didn't get nearly up to 3 times as much cost. It was more like double. In addition to having a small solar array, you've got to have a larger solar ready zone, which last code I did not include multifamily. Now that does. So both multifamily and other commercial both require both the small solar system and the larger solar ready area. So that's typically 40% of your roof area, it's 40% of the net roof area, which is the gross area, then minus all the skylights and decks and plantings and mechanical gear that's up there. So it just has to be basically set up so that it's not shaded, and that structurally it's able to calculate, it's able to handle that additional small load. And then for every 2,500 square feet, you got to have a 2-inch sleeve through the roof set up so that you can bring wiring down from the panels to your system. And then at the main panel down below, you've got to have space for that whatever other gear you're going to need as that solar ready zone becomes filled with solar at some future year. If you have a really tall building, or you're like right facing a big body of water or something else where you got a lot of wind, you need to check in with the solar manufacturer and your structural engineers to make sure that that's all in alignment. Ballasted systems might be 6 to 10 pounds per square foot, but if you actually attach it, which is pretty easy with a new project where you're coordinating with your roofing installer, then that could be 3 pounds a square foot. So some people in higher wind areas, some people would rather get things at least attached somewhat, so that you don't have to worry about the system kind of dragging itself across your roof over time. You need a certain amount of clearance, and part of that is electric code requirements to make sure that you've got space in there. So don't go chintzy on the additional wall space that is needed for that solar gear. Like I said, we got to have a quarter of a watt per square foot here. We did make one wrinkle that affordable housing projects do not have to provide this, and Other projects that don't want to put that system on their roof, or take one of the other options, have the option to donate their requirement or part of it to an affordable housing project in the city or to a solar program at the state. They everybody still has to have the solar ready roof and the solar ready panel, but it'll be interesting to see if some projects who want to use, say, their entire roof space for recreation or something, start donating some of that to affordable housing projects. If you want to know how big a quarter watt per square foot is, well, a 2-story building, that's just 3.5% of your roof. And even a 20-story building, that's 36% of your roof. And that includes the walking space. You're seeing an array here that doesn't have a walking space, but that includes walking space between rows and some other things. So in some configurations, you might be able to pack that into even smaller, below 30% of your roof. Just get real. This is advice from our friends at A&R Solar. Just make sure that you've thought through where the bathroom vents and attic fans and other kind of stuff are on your roof, and get those clustered in some spaces so that you can have a regular rectangular layout of the rest of the HVAC. Get, if you're going to do this, get an installer as part of the team early on, because they can give you some hints for how they can get that system in cheaper by just doing some minor shifts in your design.
Duane,
yes.
do solar roof areas allow for solar heating systems as well?
By solar heating, you mean solar water heating?
I'm assuming, yeah, it's preheat for domestic water.
Yeah, and a decade ago, I was very much in favor of that. PV was expensive, and you could get a lot of energy per square foot of roof space from solar water heating things. Now, with the cost of PV plummeting, and especially given that they have a very long life, I have panels up on my roof, and its whole maintenance routine is that once a year I get up there and go stand and say, wow, that's a really cool solar array. And, maybe I swab it off if there's some dust on it, maybe not. Whereas solar water heating systems require maintenance, and they have moving parts, and there's potentials for leaks, and there are other things that conspire to make their lifespan not that long. I think it's probably hard to find very many solar water heating systems that are more than a decade old. So that's my prejudice: is put PV on the roof, put good heat pump water heating system down below. Oh, and the other thing is that we get there's 4 months of the year where we get 70% of our solar input, and you can only heat up so much water, and then you're done, and then you're just dumping additional capacity. Whereas with electricity, you can feed that back into the grid. You're essentially lending it to the utility that will then lend it back to you in the winter when there's not so much sun. So you get better use out of it.
Okay, thanks.
Yeah, anybody who wants to complain to me about that, feel free, call me up later on. So commissioning, you need, if you've got more than 20 kW of lighting, which is now gotten up to be what, is that 20,000 square feet of, anyway, you got that much lighting load, and you've got, or if you've got 10 kilowatts with aux sensors, then you've got to have, you got to do commissioning for this. And commissioning is just this wonderful thing. The owner has already paid for this whole system to get designed and installed, and then it's a very small cost to have somebody come in and just, who's not the one who designed or installed it usually, to just see if it actually worked as advertised. It's a really important function. you want to just check, does it work for normal operation? Does it work for power loss? Does it, if you lose power, does it turn everything on back correctly? Are all those things that it's supposed to be doing happening? And this would be for the lighting and for those controlled receptacles you got. Let's see, would this be you, Mr. Sean?
Yeah, and one quick thing about commissioning. So the lighting industry, myself included, have a really bad habit. Somebody who's on the call here I think right now, is the person who corrected me on this, and thank you very much. We used to talk about commissioning when what we really meant was system startup. Commissioning is, of course, a third-party process. Everybody who has done HVAC stuff will know commissioning just fine because you have to commission an HVAC system. Well, now you got to commission lighting systems too. If you want to know more about this, the IES has Design Guide 29-11, which is a very dense little pamphlet that walks you through all of the steps required to do a commissioning plan and functional testing and all of this other stuff. But just remember, startup and commissioning are not the same thing. Next slide, Duane. One of the key things to remember, however, for those of you doing lighting controls in particular, you are going to need to come up with a sequence of operations. And there are a lot of different things that you need to think about for those things. This is required in order to allow a commissioning agent to be able to do their job, because if nobody knows what the system is supposed to do, how do you program it? How do you do acceptance testing? How do you figure these things out? Next slide, please. One bit that's not part of the energy code, but I am going to leave you with this anyway, is please commission the occupants, right? The people who are going to be working or studying or whatever within the spaces that you're designing lighting for, let them know what they're supposed to do. You're going to find that if somebody understands why the light fixture that's next to the window wall is dimming down every day, they're less likely to call maintenance and say, the light's not working, right? Make sure that they understand. When they understand, you're almost always going to get acceptance of what the lighting control system is doing and why. Thanks.
So we go into metering now, but I don't actually care about meters. What I care about is that the building manager, who maybe he just has a green metal desk in the basement or something like that, anyway, has a graphic display that shows them what is going on with energy use in the building to give them a clue when things are out of whack, so they can go and if the parking garage lighting was on all weekend long, and then that'll show up like a sore thumb on this display on Monday morning, and they can go and figure out if that's a sensor or a timer problem or whatever, and deal with it. So you need to have sub-metering displays for the lights and for plug loads, which concerns us. The essence of it is that there's this display that they can change to show different time periods and compare different time periods. And in addition, if a tenant has a full floor or multiple floors, then those would get sub-metering for the energy uses in that space. So that would, of course, be plug loads and lighting loads, but for some building configurations might also include mechanical loads on those floors. And that just goes to a tenant dashboard. I know that the last firm I worked at, they would have had a committee walking around with clipboards, making sure we were doing everything right if we'd had this kind of metering back. And people will complain that yeah, people might just ignore those that input. But what we're doing is we're building buildings that are capable of being run intelligently, and we're just not yet at the point where we can control the intelligence of the people who do run the buildings. Oh, I was going to mention one last thing. Metering is typically not allowed to be used to pass on billing to tenants. There's some peculiar situations where that's worked out for one reason or another, but don't just assume that you can do that. if you want to do anything like that, go talk to City Light and be nice. To run through existing buildings, we're, I guess, getting down to the end of our time here. The basic rules are you don't touch stuff no matter when it was built. You're good for as long as it's there. But what new stuff you put in has to meet code. And if you're doing something that's a substantial alteration, which I know you all love, you have to bring it up most of the way to code. And the same with a change of occupancy or a change from unheated to heated. And finally, if landmark says don't touch those windows, don't touch that entry, whatever, come to us and we can adjust your required targets. For lighting alterations, we try to keep the rules proportionate to how much work you're doing. So if you're just replacing fixtures, that means you have to meet the lighting power allowance for that space. If you're rewiring or recircuiting fixtures or adding fixtures, then you've got to have that suite of controls that works inside the space, so daylight and aux sensors and manual switches. And finally, if you're actually going to replace or relocate your lighting panel for that floor and put in new raceways out to the fixtures, which happens in a major overhaul, then you've also got to do the automatic time switch for everything that needs it. Let's see, was this going to be your slide, John?
Yeah, and if you're doing these retrofits, there are a couple of things to think about in addition to just the basic energy code stuff. From a light fixture standpoint, don't just necessarily go one for one. Pay attention to quality, right? You're trying to, if you're replacing existing lighting and it's bad lighting, don't just replace bad lighting with more bad lighting that uses less energy, right? Go ahead and review it, redesign if you have to, but if possible, even if you're redesigning, keep the existing wiring as much as you can, because that is a huge, huge cost savings right there. And you're always, well, I shouldn't say always, you're almost always going to be using less wattage than you were before. You can go ahead from a control standpoint and essentially just decommission the existing lighting controls if they're like a relay system or something, and add in a wireless system or add in LLCs to give you the controls that you're going to need while not having a huge labor bill in order to do that stuff. And if you are doing retrofits, please touch base with your local utility. City Light, if you're not in Seattle, Puget Sound Energy, Snohomish, PUD, whoever it happens to be. There are lots and lots of ways that the various utilities can help you with respect to understanding the systems, but also potentially incentive programs.
So with controlled receptacles, you have to follow those rules for new outlets you put on there, for aux sensor or time clock. But even then, if it's an alteration less than 5,000 square feet, you're not required to install the controlled receptacles. If you're just moving your office cubes around the floor, outlets that were already there, these do not require controlled receptacles in an alteration. For metering, if the whole HVAC system is being replaced, or most of it, you've got to be to put in metering for the incoming energy and sub-metering the HVAC system itself and have a normal display system. If you're doing just individual replacements of HVAC equipment, you need to have a local meter, which could be the kind that somebody has to come around with a clipboard and write it down. It's just attach the equipment there for large equipment, electric or gas. And then if you're doing one of these major alterations where you're stripping out the electrical system and putting in a new one, that needs metering. We typically use this slide with a quote from Mark Frankel, that which exists must be possible. There are project examples around town and around the country that are already well beyond where we're talking about for Seattle code, that people have done for their own reasons. This it's doable and it's here now. Um, and you wanted to give us a little send off there?
And you can actually find examples of everything they were talking about in Seattle, right? You're not going to have a real problem trying to find examples of high performance buildings in Seattle. They're everywhere. In fact, Seattle is probably one of the best places in the country for you to be able to find some of these things, lots of places. However, I will leave you, after Mr. Frankel's delightful quote there, I will leave you with The Structure as a Design in Light by Louis Kahn. And a gratuitous photo of one of my favorite projects. So this was King Abdullah University over in Saudi Arabia. It's a 6 million plus square foot college campus that we designed and built in under three years. At one time, every single HOK employee on planet Earth was working on this project. So why is this important? Well, we were throwing a lot of people and a lot of money at this, but at one time, this represented 1/2 of all of the LEED Platinum square footage on planet Earth, right? Now, why does that matter? It was complicated. One of the least complicated things about it was the lighting controls. Every single light fixture you see here is dimmable, including the outdoor ones. Every single light fixture is controlled with a networked lighting control system, 20 buildings, all able to come to one place. This was a lot of work. A lot of 3 years of my life went into designing this and the control system for this, but it's doable, right? 10 years ago, this would not have been possible. I wouldn't say 10 years. 10 years before this would not have been possible. Today, this would be relatively simple. So whatever you're doing retrofitting, make sure that you're trying to leave a better space than you found, right? All right, want to go to the final slides?
Yeah. So there's our contact information, and we still have some upcoming events here that Sean's going to take you through.
Yeah, and also before I jump through this, just a reminder, anybody on the line who has questions still, Randolph, thank you for your question, but anybody else who has questions, please ping them in. We've got a couple of minutes so we can talk about them. While I'm waiting to see if anybody else has any questions, we do have some more of the code series coming up, in particular in the next little bit here. Whys and hows of heat pump water heater systems for multifamily commercial applications, how to select and design a heat pump water heater system in your next multifamily or commercial project, and then we have 2 engineering deep dives for heat pump water heating systems. So September 15th, September 16th, October 11th and 13th, sort of here at this same channel, same time. You can find today's slide deck and video recording in a couple of days on the Lighting Design Lab webpage. You can always find what is coming up for the Lighting Design Lab on the Lighting Design Lab education page. We will have additional stuff coming up. So any other questions we can answer for folks?
And one thing today, on the 28th, we'll have one of these code things on HVAC systems.
Oh, sorry, I completely walked by it because it's not in yellow. Apologies. Yeah, I scanned right past it. All right, anybody else? Anybody else? Otherwise, if you have questions specifically about code or about lighting, meeting code, all those sorts of things, feel free to contact either of us. We're both seattle.gov, and we'll be glad to help. That's kind of what we're here for. I don't want to give away Duane's time, but I mean that is a part of what we're here for. So with that, what last word, Duane?
We got a survey that we want you to take on your way out the door. And any further questions you have, please, if you're not chatting them in right now, send them to us and we'll try to get back to you.
Yep, I'm not seeing any more in the chat. So then I will say thank you all for coming and participating, and have yourselves a fantastic sunny Seattle afternoon. Bye, everyone.